Hello, my good friends. Derek Deschamps here for Internetworking Influencers, your source for free Cisco certification training for network engineers. Welcome to day 12 of our free CCNA 100-105 ICND1 training course. The Internetworking Influencers CCNA 100-105 ICND1 training course is comprised of 13 videos, each focusing directly on a set of specific items on Cisco's official exam topic list. Today's episode will cover item 5.1, Configure and Verify Device Monitoring, using Syslog. Item 5.2, Configure and Verify Device Management, including backup and restore device configuration, licensing, logging, time zone, and loopback. Item 5.3, Configure and Verify Initial Device Configuration. And lastly, Item 5.4, Configure, Verify, and Troubleshoot Basic Device Hardening, including local authentication, secure password, access to device, including source address and telnet SSH, as well as the login banner. As a reminder, today's video has a set of free practice questions that are available on our website at internetworkinginfluencers.com that will help you brush up on the topics you learned today. The questions are a true representation of the types of questions you'll face on the actual exam, so be sure to check those out once we're done. Today we're going to start things off by looking at device monitoring using Syslog. System message logging, or Syslog, is a standard that is used for logging system messages. System messages are used to notify network engineers when specific events occur. For example, a system message can be generated after a device is configured or when an interface changes state. A system message is comprised of several components. The first component is the sequence number. This component is optional and indicates the order in which the message was generated. The second component is the timestamp. This component is also optional and indicates the time that the message was generated. The third component is the facility, which is used to indicate which protocol or hardware component generated the message. The fourth component is the severity level, which is used to indicate the severity level of the message. The fifth component is the mnemonic, which is a small string that is used to describe the message. And lastly, the sixth component is the description, which is a detailed description of the event that is being logged. For example, this system message has been assigned a sequence number of 23 and was generated on August 20th at 14:01:18. This message was generated by the Sys facility, assigned a severity level of 5, and is being described by the mnemonic config_I. And lastly, the description of the event is configured from console by user1 on console. System messages are classified based on their severity level. Each severity level is assigned both a numeric value and a keyword, which can be referenced when entering Cisco iOS commands. The severity level indicates how critical the message is. The higher the severity level, the less critical the message. For example, a system message with a severity level of 0 is considered an emergency and is the most critical, while a system message with a severity level of 7 is a debugging message that was enabled by a network engineer and is considered to be the least critical. A Syslog server is used to store system messages from multiple devices. Now that we know how system message logging works, let's take a look at how to configure it. I'll begin by logging into a router that has pre-configured interfaces and going into privileged exec mode by entering the command enable. We will now go into global configuration mode by entering the command configure terminal. Now to configure the router to timestamp the system log messages with the date and time, we can enter the command service timestamps log datetime. To configure the router to add sequence numbers to all system messages based on the order that they are generated, we can enter the command service sequence numbers. To configure the router to send system messages to the console, we can enter the command logging console. Followed by the maximum severity level of the system messages we want to send. In this case, let's send all system messages up to a severity level of informational. To configure the router to send system messages to Telnet or SSH sessions that have issued the terminal monitor command, we can enter the command logging monitor. Followed by the maximum severity level of the system messages we want to send. In this case, let's send all system messages up to a severity level of debugging. To configure the router to send system messages to the logging buffer, we can enter the command logging buffered. Followed by the maximum severity level of the system messages we want to send. In this case, let's send all system messages up to a severity level of notifications. To configure the router to send system messages to a Syslog server, we can enter the command logging trap. Followed by the maximum severity level of the system messages we want to send. In this case, let's send all system messages up to a severity level of critical. Now, to configure the IP address of the Syslog server, we can enter the command logging host. Followed by the IP address of the Syslog server. In this case, 10.1.1.25. Now, if we exit out of global configuration mode by typing exit, we can see that a system message has just been sent to the console. We can also see that this system message begins with a sequence number of 19, followed by a timestamp that contains both the date and time that the message was generated. Now, to verify our configuration and to view the logging buffer, we can enter the command show logging. Here we can see that console logging has been set to a severity level of informational. This means system messages up to a severity level of informational will be sent to the console. Next, we can see that monitor logging has been set to a severity level of debugging. This means system messages up to a severity level of debugging will be sent to Telnet or SSH sessions that have issued the terminal monitor command. Next, we can see that buffer logging has been set to a severity level of notifications. This means system messages up to a severity level of notifications will be sent to the logging buffer. Next, we can see that trap logging has been set to a severity level of critical. This means system messages up to a severity level of critical will be sent to the Syslog server. We can also see that the Syslog server has been set to 10.1.1.25. And lastly, we can see the contents of the logging buffer, which already contains a system message. System messages will be stored in the logging buffer until it is manually cleared or the device reboots. To clear the logging buffer, we can enter the command clear logging. Now, if we enter the command show logging, we can see that the logging buffer has been cleared. The next topic we will look at today is device licensing. Traditionally, multiple Cisco iOS images were available for each device. Each iOS image supported a different feature set, and iOS was chosen based on the features that were required. Today, there is simply one universal image for each device that contains all feature sets. When a specific feature set is required, it can be unlocked by purchasing a feature set license. Once a feature set has been purchased, it can be activated using the following steps. The first step is to download the license file from the Cisco Product License Registration Portal, which can be found at www.cisco.com/go/license. In order to download the license file, you will need to enter a product authorization key, or PAC, which will be provided at the time of purchase. You will also need to enter the Unique Device Identifier, or UDI, for the device you wish to activate the feature set on. The Unique Device Identifier can be obtained using the Show License UDI command. The second step is to install the license file using the License Install command. The third step is to reload the device using the Reload command. The Cisco License Manager, or CLM, is a free software application that is used to manage Cisco licenses from a central location. Cisco License Manager is an alternative to manually installing licenses. Cisco License Manager can discover what licenses are required, acquire license files from the Cisco Product License Registration Portal, and deploy licenses across the network. Now that we know how feature sets are activated, let's take a look at a few licensing commands. The Show License UDI command is used to display a device's Unique Device Identifier, or UDI. The Unique Device Identifier is required to download a license file. Here we can see the Unique Device Identifier is a combination of both the product ID or PID and the serial number. The License Install command is used to install a license file. In this example, the License Install command has been used to install a license file from a TFTP server. The Show License command is used to display license information for feature sets. In this example, we can see the license information for the IP base feature set. The Show License Feature command is used to display which feature sets are available. In this example, we can see that 4 feature sets are available to be licensed. The license boot module command is used to install a built-in 60-day evaluation license for a specified feature set. In this example, the license boot module command has been used to activate a 60-day evaluation license for the security feature set. Once the command is entered, an end-user license agreement must be accepted before the feature set can be used. For this next topic, we will look at various Cisco iOS features that can be used for device management. Setup mode is used to set up the initial configuration of a device. Setup mode is automatically accessed when a device boots with no configuration file. Setup mode can also be accessed using the setup command. The system clock is used as a time reference when logging system events. The system clock can be set automatically using NTP. The system clock can be set manually using the clock set command. A loopback interface is a virtual interface. A loopback interface will always remain up unless manually shut down. A loopback interface can be assigned an IP address, which is often used to access the router remotely. For example, with this network, a loopback interface named Loopback 0 has been created on router 1. Loopback 0 has been assigned the IP address 10.0.0.1 with a subnet mask of 255.255.255.0. Unlike router 1's physical interfaces, Loopback 0 will always remain up unless manually shut down. The IP address of Loopback 0 can be used to access the router regardless of the state of its physical interfaces. This makes it the ideal IP address to use when accessing the router remotely. A device's configuration can be backed up to a remote location, such as a TFTP server, FTP server, or USB flash drive. A device's configuration can be backed up and restored using the copy command. Now that we know how these device management features work, let's take a look at how to configure them. I'll begin by logging into a router that has pre-configured interfaces and going into privileged exec mode by entering the command enable. The first device management feature we will look at is how to enter setup mode. Setup mode will automatically be accessed when a device boots with no configuration file. Setup mode can also be accessed by typing the command setup. As you can see, we have now entered setup mode. Setup mode consists of a system configuration dialog that will ask a series of questions in order to create an initial configuration file. In this case, we won't go through all the questions because we want to manually configure the router. So when asked if we want to continue, we will simply answer no. The next device management feature we will look at is how to manually set the date and time of the system clock. To do this, we must first go into global configuration mode by entering the command configure terminal. Now the first step to manually setting the date and time of the system clock is to configure the time zone. To configure the time zone, we enter the command clock time zone. Followed by the name of the time zone, in this case, EST. Followed by the hours offset from UTC, in this case, -5. We can now configure daylight savings time by entering the command clock summertime. Followed by the name of the time zone when daylight savings occurs. In this case, EDT. Now, to have daylight savings time automatically be applied each year, we can enter the keyword recurring. We can now specify the date and time that daylight savings should occur, or we can simply use the default United States standard by hitting enter. We can now exit out of global configuration mode by typing exit. Now that the time zone and daylight savings time have been configured, we can now set the date and time of the system clock by entering the command clock set. Followed by the time, in this case 12:00:00, followed by the date, in this case the 15th of August 2019. We can now display the system clock by entering the command show clock. Here we can see that the system clock has been successfully set. The next device management feature we will look at is how to create a loopback interface. To do this, we must first go into global configuration mode by entering the command configure terminal. We can now create a loopback interface by entering the command interface loopback. Followed by a number to identify the interface. In this case, let's use 0. Interface loopback 0 has now been created and placed into an up state. And as you can see, the command prompt has now changed to config-if in parentheses. This indicates we have now entered interface configuration mode for this interface. Now, to configure an IP address on this interface, we can enter the command IP address. Followed by the IP address. In this case, 10.0.0.1. Followed by the subnet mask. In this case, 255.255.255.0. Now, if we exit out of interface configuration mode by typing exit, and exit out of global configuration mode by typing exit again, we can verify our configuration by entering the command show interfaces loopback 0. Here we can see that interface loopback 0 has been created and placed into an up state. We can also see that this interface has been assigned the IP address 10.0.0.1 with a /24 subnet mask. The next device management feature we'll look at is how to back up the running configuration to a remote location. To do this, we enter the command copy running config. Followed by the destination. In this case, let's back up the running configuration to a TFTP server by entering the keyword TFTP:. We are now asked to enter the IP address of the TFTP server. In this case, the IP address is 10.1.1.50. We are now asked to enter the destination file name. In this case, let's call it backup-config. The running configuration has now been successfully backed up to the TFTP server. Now, if we wanted to restore our running configuration from the TFTP server, we could enter the command copy TFTP: running-config. We are now asked to enter the IP address of the TFTP server. In this case, the IP address is 10.1.1.50. We are now asked to enter the source file name. In this case, the source file name is backup-config. We are now asked to enter the destination file name. In this case, the destination file name is running-config. Since this is the default, we can simply hit enter. The running configuration has now been successfully restored using our backup. The last topic we will look at today is device hardening. There are 3 ways to connect to the command line interface of a Cisco device: by connecting physically to the console port, or by connecting remotely using Telnet or SSH. The console port connects through a terminal line called line con 0, while both Telnet and SSH connect through virtual terminal lines, also referred to as VTY lines, which are numbered from 0 to 15. Access can be restricted to both the console and VTY lines by using a password only. This can be configured using 2 steps. The first step is to define a password on the line using the password command. The second step is to enable password checking on the line using the login command. For example, on this device, a password has been defined on both the console and VTY lines using the password command. Password checking has also been enabled on both the console and VTY lines by using the login command. Now, anytime a user attempts to connect to the device via the console port or Telnet, they will be required to enter the password. It is important to note that although SSH also uses the VTY lines, this particular configuration will only work with Telnet. Access can also be restricted to both the console and VTY lines by using usernames and passwords. This can be configured using 2 steps. The first step is to define username-password combinations using the username command. The second step is to enable password checking on the line using the login local command. For example, on this device, 2 username-password combinations have been defined using the username command. Password checking has then been enabled on both the console and VTY lines using the login local command. Now, anytime a user attempts to connect to the device via the console port, Telnet, or SSH, they will be required to enter a valid username and password. The username command can be used to define a username-password combination using one of 2 methods. When the username command is used with the password keyword, the password is stored as clear text. When the username command is used with the secret keyword, the password is stored as an MD5 hash. Secure Shell, or SSH, is a secure method of connecting to a Cisco device. SSH is enabled by generating an RSA key. There are 3 steps to generating an RSA key. The first step is to define the hostname using the hostname command. The second step is to define the domain name using the IP domain name command. The last step is to generate an RSA key using the crypto key generate RSA command. The transport input command is used to specify which protocols are allowed to connect to the VTY lines. For example, here we can see the transport input SSH command has been used on all VTY lines to allow only SSH connections. The access class command is used to apply an access list to the VTY lines. For example, here we can see access list 1 has been created to match the source IP address 10.1.1.25. This access list has been applied to the VTY lines in an inbound direction using the command access class 1in. Now that this access list has been applied, only the source IP address 10.1.1.25 will be allowed to connect to the device through the VTY lines. The enable password command is used to set a password for entering privileged exec mode. With the enable password command, the password is stored as clear text. The enable secret command is also used to set a password for entering privileged exec mode. With the enable secret command, the password is stored as an MD5 hash. The enable secret command takes precedence over the enable password command when both are configured. The service password encryption command is used to encrypt all clear text passwords in the running configuration. The service password encryption command uses a weak form of encryption that can be easily decrypted. A banner is used to display a message to users during the login process. A banner is typically used to display a legal notice or outage notification. A banner is configured using the banner command. There are 3 types of banners that can be configured. The message of the day, or MOTD banner, is displayed prior to login for console and telnet connections, and is displayed after login for SSH connections. The login banner is displayed prior to login, while the exec banner is displayed after login. Now that we know how these device hardening features work, let's take a look at how to configure them. I'll begin by logging into a router that has pre-configured interfaces, and going into privileged exec mode by entering the command enable. We will now go into global configuration mode by entering the command configure terminal. Now, if we want to enable SSH access to the router, we will first need to define both the host name and domain name. To define the host name, we enter the command hostname, followed by the host name, in this case, router 1. To define the domain name, we enter the command IP domain name, followed by the domain name, in this case, Internetworkinginfluencers.com. We can now enable SSH by generating an RSA key. To do this, we enter the command crypto key generate RSA. We are now prompted to specify the size of the modulus. A large modulus is more secure, but takes longer to generate. In this case, let's use a modulus size of 1024. Now, if we want to configure the router to encrypt all clear text passwords, we can enter the command service password encryption. Now, to configure a username password combination on the router, we enter the command username followed by the username, in this case, Derek, followed by either the keyword password or secret. In this case, let's store the password as an MD5 hash by entering the keyword secret. Followed by the password, in this case, let me in. Now let's create an access list to match the source IP addresses that we want to allow access to the device. To do this, we enter the command access list followed by the access list number. In this case, let's assign the access list the number 1. Followed by permit, followed by the source IP addresses we want to permit. In this case, let's permit only the source IP address 10.1.1.1. Now to configure the console port, we enter the command line con 0. As you may have noticed, the command prompt has changed to config-line in parentheses. This indicates we are now in line configuration mode. Now, if we want to restrict access to the console port by using a password only, we enter the command password followed by the password. In this case, 12345. Now to enable password checking on the port, we enter the command login. Now that these commands have been entered, each time a user attempts to connect to the console port, they will be required to enter the password. We can now exit out of line configuration mode by typing exit. Now to configure the virtual terminal lines that are used for Telnet and SSH connections to the router, we enter the command line VTY followed by the number of the first VTY line, in this case 0, followed by the number of the last VTY line, in this case 15. Now to enable password checking using usernames and passwords, we enter the command login local. Now that this command has been entered, each time a user attempts to connect using Telnet or SSH, they will be required to enter both a username and password. Now to specify which protocols are allowed to connect to the VTY lines, we can enter the command transport input followed by the protocols we want to allow. In this case, let's allow both Telnet and SSH. Now to apply an access list to the VTY lines, we can enter the command access class followed by the access list number of the access list we want to apply. In this case, 1. Followed by the direction. In this case, in. Now that this access list has been applied, only source IP addresses that match access list 1 will be allowed to connect to the device through the VTY lines. We can now exit out of line configuration mode by typing exit. Now to configure and enable secret password, we can enter the command enable secret followed by the password, in this case, my secret. Now to configure a message of the day banner, we can enter the command banner MOTD. Followed by a delimiter character. A delimiter character is used to indicate both the start and end of the banner message. When choosing a delimiter character, be sure to pick a character that is not contained within the banner message itself. In this case, let's use hash. Followed by the message. Followed by the delimiter character again. Now to configure a login banner, we can enter the command banner login. followed by a delimiter character, in this case hash. Followed by the message. Followed by the delimiter character again. Now to configure an exec banner, we can enter the command banner exec. Followed by a delimiter character, in this case hash. Followed by the message. Followed by the delimiter character again. Now if we exit out of global configuration mode by typing exit, and enter the command show IP SSH, we can see that SSH has been enabled. And if we enter the command show running config pipe include secret, we can see that both the enable secret and username secret passwords have been stored as an MD5 hash. And if we enter the command show running config pipe section line con 0, we can see that the console password has been encrypted using the service password encryption command. Now, if we log out of the router by entering the command logout, and attempt to log into the console port, we can see that the message of the day banner and the login banner are now being displayed prior to login. We can also see that we are now being prompted for a password. And if we log in by entering the password 12345, we can see that the exec banner is now being displayed after login. Now, if we attempt to go into privileged exec mode by entering the command enable, we can see that we are now being prompted for the enable password. And if we enter the password my secret, we are granted access to privileged exec mode. Now that we've verified our console configuration, let's verify our telnet configuration. To do this, we can telnet to the router using the telnet command. Here we can see that the message of the day banner and the login banner are being displayed prior to login. We can also see that we are now being prompted for both a username and password. And if we enter the username Derek, followed by the password "let me in," we can see that we are able to log in using a username and password. We can also see that the exec banner is being displayed after login. Now that we've verified our telnet configuration, let's verify our SSH configuration. To do this, we can SSH to the router using the SSH command. When using the SSH command, we must include the -L option to specify the username. In this case, Derek. Here we can see that when using SSH, only the login banner is displayed prior to login. We can also see that we are only prompted for a password, since the username was specified when we entered the SSH command. Now, if we enter the password that's associated with this username, in this case, "let me in," we can see that we are able to log in using a username and password. We can also see that both the message of the day banner and the exec banner are being displayed after login when using SSH. And that brings us to the end of day 12 of Internetworking Influencers CCNA 100-105 ICND1 training course. Don't forget to complete the free practice questions for today's material, which can be found on our website at internetworkinginfluencers.com. The free questions will help highlight the key points that Cisco will expect you to know for the exam. Also, if you enjoy our free training and would like to show your support, please check out our Patreon page. We offer numerous perks to our supporters, ranging from additional practice questions and detailed study notes for each video, to direct access to our instructors to answer any questions you might have. I'll be back next time for day 13, where I'll cover iOS upgrades, password recovery, and iOS tools. I'm Derek Deschamps for Internetworking Influencers. Thanks for watching.